This video is going to talk about various measures of spread, specifically range, variance, and standard deviation. Now, standard deviation is going to be our main concern here. That's what we're going to be using a lot throughout this class. And basically what standard deviation measures is the overall variation in a data set, okay? And you can use it to determine how far a data value is from the mean. So if you had a set of data where everything in the set of data was in one place, okay, then there would be no variance, there'd be no variability in that data set. So our spread would be 0, okay? You would just have that mean. Whereas if you have a data set that has variability, right? We want to be able to measure that variability from the center of the data. So there's an example here in which two customers are at a supermarket, okay? And the average wait time at both supermarkets is 5 minutes. Supermarket A, standard deviation is 2. Supermarket B, the standard deviation is 4. So both of them have an average wait time of 5 minutes, but the spread of wait time for A is less than the spread of the wait time for B. It is more likely to have to maybe wait longer in line, if you want to think of it that way, at B. Okay, there's more variation in the wait times at supermarket B. It's more spread out from the average. Now, let's say that Rosa and Bean both go to supermarket A. Rosa waits at the checkout counter for 7 minutes, and Bean or Ben, I'm not quite sure how to pronounce that, only waits for 1 minute. Now, remember, at supermarket A, the mean wait time is 5 minutes with a standard deviation of 2. Since that is all wait times, I can use population parameters. So we can say that M is 5. And then for standard deviation, the population parameter we use is sigma for standard deviation. Okay, so we say sigma equals 2. Here is a breakdown of this situation here in words. So if Rosa waits for 2 minutes longer than the average of 5, then her 2 minutes is 1 standard deviation above the mean. Think about that in a number line. Okay, this is 1 standard deviation above the mean, and this is Rosa's wait time here. If I look at Bean's wait time, she's 4 minutes less than the average of 5. So here would be 1 standard deviation below at 3, and then 2 standard deviations below at 1. So her 4 minutes is 2 standard deviations below the mean. Therefore, her time here is more rare than Rosa's. We can use that as a comparison here. You can also use this number line down here below. I drew it off to the side up here, but you can use this number line down here below to model this if you would like to. Now we use the lowercase letter s to talk about the sample standard deviation, just like we used x bar to talk about the sample mean. And then we use Greek letters to talk about the population standard deviation. We had just talked about that. There is some equations we can use to actually mathematically calculate both the variance and the standard deviation. So a number's difference from the mean is called its deviation from the mean, how far it deviates from what the average is. If you find all of those, either x minus mu's or x minus x bars. For example, let's use rows. So 5 was the mean. She was at 7, and so her deviation is 7 minus 5, which is 2. Now, the variance is the average of all the different deviations. And we're going to square those so that it doesn't matter if you are at 3, because that would be -1 standard deviation, or a deviation calculation here of -2, because you're down 2 from here, or 7, you're still a deviation of 2 from the mean, or 1 standard deviation below the mean. Therefore, we need some way to make sure all the deviation calculations here stay positive. So we're going to do that by squaring. And then we're going to add those all up. And you can see there are some calculations here, and we'll do some of these in our example here in just a second. All right, let's look at our example and pull this all together, okay, and talk about the difference between each one of those vocabulary words. If you don't have StatCrunch already up and going, this would be a good time to pause the video and go ahead and get that set up. All right, so in this example, we have a 5th grade class, and the teacher wants to know the average age and standard deviation of her students. And we see that this is a sample of 20 students. Here are the ages rounded to the nearest half year, and let's find the mean. Now we're just going to do a little bit of some of the calculations, and then we're going to let StatCrunch do the heavy lifting for us. But since this is a sample, we're going to find the mean by calling it x bar, and I would add all 20 of these students up, their ages, and then divide by 20. And again, we're going to use StatCrunch to find that for us in just a second. Now, the range, we didn't talk about that in our vocab words, but the range is always the max minus the min. So that's 11.5 to 9, or 2.5 years. All right, for our variance equation, let's go up here. Now, variance, does it say it? No, I think it just gives you it for standard deviation. Okay, so variance is the sum of the squares. And what that means is you're going to add up each and every x minus x bar and square it. And then since this is a sample, we're going to divide by n minus 1. For example here, that would be 9 minus whatever we find the mean to be here in just a second. So I'm just going to write that as x bar squared plus all the way up to 11.5 minus x bar squared all over 19. Then to find the standard deviation, because this would then be in like units squared, right? So this would be like in years squared, but I don't want that unit to be in squares. So I'm going to take the square root of my variance to make sure that I get back to years. And then standard deviation is what we'll report with the mean. All right, let's pull this up into StatCrunch. All right, so if you don't already have the video or if you don't already have the data plugged into StatCrunch, you might want to pause the video and then go ahead and plug that in here. All right, so back even 10, 15 years ago, we would have done all those calculations on a calculator, but still by hand. And the chance of error is really, really high. So we're going to just use programming to do this for us now and understand what these mean versus spending all of our time on calculating. So we're going to go to summary statistics, okay? And I have everything in that variable 1 column, so I'm going to choose column. If I had a frequency table of like 9 with a 1, 9.5 to 10 with a 4, then I would maybe want to use grouped binned data, but I don't. I have all 20 students' ages in that first column. So I'm going to say select that. And then the statistics I'm interested in calculating are mean, variance, and standard deviation. And you can see there's little words there that tell you to press shift and then click, okay, to do everything in between. And let's say compute. Beautiful. So see, it does all of that for us. So that says the mean is, we're just going to say 10.5. I'm going to have to click back and forth a little bit between here. So the average age in class is 10.5. We'd have to find that first. And then if we were to do this by hand, we'd have to do 9 minus 10.5 squared plus 9.5 minus 10.5 squared plus blah, 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 blah. Okay, and again, we're squaring to make sure numbers that are below the mean get counted positive, okay, and numbers above the mean get counted positive. But what that does is it makes our units squared. We divide by 19. We'll talk more about degrees of freedom later on in our time together. So just know you divide by n minus 1, but that still doesn't take care of your units. So then we need to talk about standard deviation. So our variance was 0.5. Let's go to 2 decimal places, 0.51. And if I take the square root of 0.51, I should get 0.7, and then I think rounded, it's 3, and that's fine if you just want to round 0.72. So this would be our variance. Again, that's with years squared, which makes no sense. So our students in this class vary from the mean by about 0.72 years is what that means.